Section 1.7, Solving Absolute Value Equations and Inequalities. We're going to look at this section in three pieces. The first part is solving absolute value equations. The important thing to remember with absolute value is absolute value means distance from zero on the number line. That's the reason, for example, that the absolute value of -4 is 4 and the absolute value of +4 is 4, because -4 is 4 units away from 0 on the number line, and +4 is 4 units away from 0 on the number line. Here on the right-hand side, you see an algebraic definition of the absolute value of x. This is what's called a piecewise definition. The definition is in three pieces depending upon the domain to which you are referring. So the absolute value of x is just x as long as x is positive. For example, if x is 3, the absolute value of 3 is 3. The absolute value of x is 0 if x is 0. Simply means the absolute value of 0 is 0. And finally, the absolute value of x is the opposite of x if x is negative. For example, if x is -3, the absolute value of -3 is the opposite of -3, or +3. So in solving an absolute value equation, when you remove the absolute value bars, you actually separate the absolute value equation into two separate equations. When I say that the absolute value of 6x minus 3 is equal to 15, I know that the quantity inside the absolute value bars could be positive 15, because the absolute value of 15 would be 15. That would be a true equation. The quantity inside the absolute value bars could be negative 15, because the absolute value of negative 15 is also 15. That would be a true equation. So when I remove the absolute value bars, I set up two separate equations connected by the conjunction or. 6x minus 3 equals 15, or 6x minus 3 equals negative 15. I solve each of those equations, get the two solutions to the absolute value equation. These are the algebraic solutions. The geometric or graphic solutions would be indicated here, -2 or +3. Pause this presentation and try number 35 on page 53. So number 35, the absolute value of 2n minus 5 is equal to 7. The quantity inside the absolute value bars could be 7 or -7. So I express that as two separate equations connected by the conjunction or. Solve each of those equations, and I get the algebraic solution, n is equal to 6 or -1. The geometric or graphic solution, -1 or 6. The second part of this section we're going to look at is absolute value inequalities, but specifically the less than inequality. So again, it's important to remember that the absolute value means distance from 0 on the number line. So when I say, for example, that the absolute value of x is less than 4, then the solution set would be all those values of x that are less than 4 units away from 0 on the number line. That means I could start at 0 and go 4 units to the right, start at 0 and go 4 units to the left. And all these highlighted values would be less than 4 units away from 0 on the number line. Algebraically, these highlighted values would be expressed as x is greater than -4 to the right of -4, and x is less than +4 to the left of +4. So that concept is going to be applied throughout these absolute value inequalities where the inequality symbol is less than. So for example, when I say the absolute value of 4x minus 9 is less than or equal to 21, that means I could start at 0, less than or equal to 21 units away from 0 on the number line, go 21 units to the right, start at 0, go 21 units to the left. All these values, all these shaded values, are less than 21 units, less than or equal to 21 units away from 0 on the number line. Algebraically, I would express that as 4x minus 9 is greater than or equal to -21, and 4x minus 9 is less than or equal to positive 21. Then I go ahead and solve that compound inequality. I get the algebraic solution for x, and I can express that graphically or geometrically here. X is greater than or equal to negative 3, and x is less than or equal to 15 halves. Pause this presentation and try number 51 on page 54. So here, the absolute value of x minus 8 is less than or equal to 5. So less than 5 units away from 0 on the number line. Less than or equal to 5 units away from 0 on the number line. 0, 5 units to the right. 0, 5 units to the left. So all these shaded values algebraically I can express as x minus 8 is less than or equal to 5 and x minus 8 is greater than or equal to negative 5. Go ahead and solve that compound inequality for x. My algebraic solution would look like x is greater than or equal to 3 and x is less than or equal to 13. Graphically or geometrically, I can express that those values, that solution set, like this. In the last part of section 1.7, again, absolute value inequalities, but this time the inequality symbol is greater than. Again, absolute value means distance from 0 on the number line. So if I make the statement the absolute value of x is greater than 4, then the values of x that satisfy that inequality are all those values that are more than 4 units away from 0 on the number line. So starting at 0, I go 4 units to the right. All the values that are more than 4 units away from 0 are all these values out here. Starting at 0, I go 4 units to the left. All the values that are more than 4 units away from 0 on the number line are out here to the left. And this geometric representation can be expressed algebraically as x is greater than 4 or x is less than negative 4. X is less than negative 4. So that concept is going to be applied when I solve these absolute value inequalities where the inequality symbol is greater than. So to solve the absolute value, 3x minus 2 is greater than 18. Starting at 0, I move 18 units to the right, and all the values would be out here to the right of 18, more than 18 units away from 0 on the number line. Starting at 0, I move 18 units to the left, and all the values that I'm interested in are more than 18 units away from 0, so all these values out here to the left. Algebraically, this is 3x minus 2 is greater than 18. 3x minus 2 is greater than 18. Or, this part, 3x minus 2 is to the left of or less than negative 18. Solve each of those simple inequalities individually. Connect with the conjunction or. X is less than negative 16 thirds, or x is greater than 20 thirds, graphically or geometrically is represented here on this number line. Pause this presentation and try number 52 on page 54. The absolute value of x minus 16 is greater than 24. So more than 24 units away from 0 on the number line. Geometrically, positive 24, negative 24, more than 24 units away from 0 would be to the right of positive 24, to the left of negative 24. Algebraically, that means that x minus 16 is greater than 24, or x minus 16 is less than negative 24. Solve each of those individually, connect with the conjunction or. I have the solution set algebraically as x is less than negative 8, or x is greater than 40. Geometrically or graphically can be represented like this on the number line.